So welcome to Are You as Smart as a Tableau Consultant? Or I'm going to be more specific, Are You as Smart as a Tableau Product Consultant? My name is Bronson Shank, and I'm a Senior Product Consultant at Tableau. I've been here for 3 years. I'm actually moving on in January. I'm going to be working as an analyst still at Tableau for our support team. So some of you said you saw this, you're familiar with the challenge workbook. Last year I presented on this. I'm going to give you a brief overview of what it is, and then for those of you who are familiar with it, don't worry, we've got some new content for this time. But the challenge workbook is this collection or library of Tableau challenges. I'll give you some context for how this thing came about. So as a product consultant, my job is to get on the phone with customers when they're learning about Tableau and help them solve problems or give demonstrations and all that kind of stuff. So essentially, I would get on the phone over and over when I first got here, and people would just stump me with their data problems over and over again. And I started to kind of pick up on some trends. People were coming to me with different questions, different data, totally different companies and genres. But the foundation of the questions that they were asking were all the exact same. There were these really fundamental problems of working with data. And so as I started to get on these calls, I figured, well, I should probably collect these and make it easier for myself. So what I did is I started this folder on my desktop, and I called it Tableau Concepts. And so every time I would come across a new problem, I would create a workbook of it. And I would basically document in that workbook. I would write, OK, what's the problem? Really explain it well with some kind of sample data. And then how do you actually solve it? And what this did for me is it automated my job. And so over time, I started to collect more and more of these. I got on more and more calls, and this folder started to fill. And eventually, I had this massive folder of basically what I would call data concepts. And so like I said, this automated my job. I would get on the call with a customer. They would ask me a question. I'd say, I got the answer. Here you go. Send it off. We're done in 5 minutes. My life's easy. I can focus on other things. So this turned out to be a really incredible way for me to learn our product, just constantly getting challenged with all these things. And I realized more people could use this. So what I did is I wrapped it all up into a Tableau workbook, and I published it up to our server, and I made it accessible to all of my coworkers. And what I did is I categorized them, and I ranked them by difficulty, so that every time we had a new hire come in, I didn't have to teach them anything. I just said, go study this, and when you have a problem, come to me. So it helped out a lot in terms of just scaling our team. So last year, I ended up actually making this public completely. I put it on Tableau Public, and so now it's accessible to all of you. For those of you who aren't familiar with it, I'm going to show you a link right after this, and you can go ahead and try them on your own. But today's session, I figured we should focus on problem solving. So specifically, problem solving in general, but more specifically, problem solving in Tableau. So how do you take some question and then figure out an effective way of solving it? We're going to do that with a couple different examples from the actual challenge workbook. But before that, I wanted to kind of set the stage with just some problem-solving examples in general. So outside of my day job, I'm an artist. I spend a lot of time drawing. I have a couple of stuff showing in Seattle right now, and I'm working on a show for January. So what you're seeing here is one of my pieces. And this didn't start like this. This started as an idea or a vision in my head. And I realized not too long ago that art, any type of art, whether it's music or drawing, is very much a problem, right? You start with some vision in your head, and the idea is how do you close the gap between what's in your head and what's on paper, between what you hear in your head and what you play on the guitar. And so art is very much this problem, right? And so I want to walk you through how I work through an art problem. So this problem, if we actually go back to this, what I realized when I had this in my head is that it's very, very complex, right? It's got kind of layers, and everything's overlapping and weaving in and out. And I realized that I couldn't just simply sit down and draw this. It would be too mathematical to figure out all of the overlap. And so as I started to think about it and truly understand why this was difficult, I realized, well, the issue is layers. I need to be able to flexibly put different layers on top of each other and move them around. And so it took me about a year actually looking into this to figure out a good way of approaching it. And what I found is that Photoshop is really, really incredible. It allows you to take all these different images and make layers and put them on top of one another. So this was this awesome discovery, and I realized, OK, well, now I have this thing that I can use to solve this problem. What do I do next? So I took it, and then I broke it into smaller pieces. I said, well, I can draw smaller drawings, many of them, and you can see some of them up here, and then I can put them into Photoshop individually and then layer them on top of each other to finally close that gap between what's in my head and what's on paper. So art is not the only problem-solving thing that we deal with, nor is data. How many people here flew to get here? All right, good. So everybody has done this once or twice, right? We think, OK, we've got a 10 a.m. flight. If it departs then, how do I figure out when to leave my house? Well, an effective way of doing this is to work backwards. If I want to arrive at the airport at 10 a.m., then I want to, or if I want to depart at 10 a.m., then I want to arrive at the airport at, say, 8:30. That's going to give myself about an hour and a half to get through security and whatnot. I'm kind of safe, so I give myself more time. If I want to arrive at the airport at 8:30, then I want to leave my house by 8 a.m. because I need to account for traffic. That's part of the problem. And if I want to leave my house by 8 a.m., then I want to wake up at about 7:15 because that gives me 45 minutes then to wake up, eat breakfast, shower, shave, and pack. So let's think about all the problem-solving techniques that we just used to solve those general problems, right? The first one is, with my art, I truly understood why it was difficult and why it was a problem, right? I spent a lot of time learning about why the layers were difficult and then working backwards. So if we look at that airport problem, it's really, really simple, right? It's kind of a trivial thing that we do. But by working backwards, we make it really easy for ourselves to figure out an answer. And then lastly, breaking down the problem, I'm just also throwing up really random words that I found on the internet, retrograde analysis and chunking. I saw it in a TED Talk, so it's got to mean something. So chunking, or breaking down the problem, essentially taking that problem and putting it into smaller parts. So we took that airport problem and we broke it into smaller parts. There's the problem of security, the problem of traffic, the problem of waking up, right? So all these things that we can use then to get a solution. So these are general problem-solving techniques that we use, and we're going to actually try to focus on these as we go through the problems. But here is what we're going to actually, the things that we'll actually practice here. So common data, concepts, or you could call them problems, whatever it is. So they are visual layout, creating data, and reshaping data. These are what I would kind of categorize everything into. And it's not black and white. Many different things include both of these. But we're going to focus on these three, and we'll go through 3 different examples that focus on them. Don't worry about what they are now. As we go through it, you'll get an idea of it. So the agenda, the 3 challenges that we're going to try, these are all in the challenge workbook except for the last one. All the material is available to you. I'll show you where you can get it after this. So a trellis chart, open and active items, and then second purchase date. So as we go through this presentation, I want you to really think about this because some of the stuff we're going to do might be beyond what you currently know if you're not that familiar with that level of detail expressions or table joins are new to you or table calcs are new to you. But what's important is to understand the concepts that we're learning, and then you can take this stuff after and really learn it and then apply it to your own data. All right, so y'all ready? Anybody seen this before? So a trellis chart, that's another fancy name for columns and rows, right? If you have a Word document, you can put all your text into different columns. That's essentially what a trellis chart is. So one technique we can use is to restate the problem. Try to understand this from different angles. Everybody's familiar with this, right? This is just a very simple graph. It looks kind of pretty, it looks like a drawing, but it's actually just a very simple graph. So if we were to break this down to the foundation of what makes up this graph, there's an x and a y-axis. Pretty simple. There's size, there's sort of shape, there's a mark type, and there's color. So we break that down, we can really see there's an x and a y, right? Do you know what the x and y represent? Anybody? Coordinates, right? It's probably Latin longitude. The size represents the size of the army. The color, in this case, represents the direction that the army is moving, right? And then you can see as it dwindles and they come back. So let's do one more of these. So this is more of a typical chart that you've looked at, right? Once again, an x and a y-axis. And what this chart is really made up of is 5 different coordinates, right? So those are the 5 different coordinates up there that are plotted based on an x and a y coordinate. The mark type here is a bar chart. We've just extended a bar up to hit that mark. And we've got color, which doesn't really mean anything here, and the size is essentially the size of the bar. So if we look at Tableau, what you're going to find is that these same concepts repeat themselves. Really, all we're working with in Tableau is an x and a y axis, columns and rows. We have a marks card for size, color, shape. We can change our mark type, line, bar chart, etc. These are all things that we can use to create many different types of graphs. So let's come back to our problem. Right? We're trying to create a trellis chart, which is essentially a cell for every single mark. So we have an x and a y axis. So each one of these is actually just a coordinate. So 0, 0, 0, 1, or 1, 1, however you want to call them. But what we need to figure out is how to then assign those to the different marks or the different pie charts in this one. And what we're looking at is not all that important, whether it's pie charts, or numbers or anything else. So you can see here, then we can actually fit this to this, and then we can add coordinates to each one. But what we've done is now we've truly tried to understand the problem that we have, right? And so what should be my next step that I understand it? Who's paying attention? Oh. Next one, we'll do that. All right, working backwards. So if we're going to work backwards, let's actually bring this into Tableau and start to apply the things that we just learned. So really, we have an x and a y axis, which means we need two columns. One is x and one is y. And one is going to have the y coordinates, and one is going to have the x. So we'll have 0, 0, 0, 1, 1, 0, et cetera, so on and so forth. So let's take a look at the data that we're working with. This is just sample Superstore. You've probably seen it before. But what we've got is just states. Now, the problem, obviously, is that states are just in a long list. It's a single column with all the states down. In this data set, we have 49 states. So we need 49 unique coordinates to create that chart. So this is what we're going for. If we can assign an x and a y uniquely to every single state, then we can very easily just put the state on the level of detail, on the detail shelf, and then we can put the x and the y axes on their columns and rows respectively. Now we get to the hard part. We actually have to figure out how to do this. But what we've done here is we've essentially simplified the problem, and there are many different ways of actually getting to that solution. I'm going to show you one way, but the point is that we all know where we need to get to. So how do you get there? You can do that on your own, but I'm going to show you one way to do that here. Give me a sec to switch the screen. All right. So here's our data set. We just bring in states to rows. So I'm going to just kind of visually build this out to the point where I want to get to. So we have all our states. Now we have to assign an x and a y coordinate. So what I'm going to use is a table calc. And I'm going to use some trickery, basically, to tell this table calc to start restarting every 7 or so states so that we can get 1, 2, 3, 4, 5, 6, 7 for x and y, and do that repeatedly to get a bunch of unique points. So the trick that I'll use, we'll build this first with an index. This is a table calculation for those of you not familiar with it. And I'm going to use these. If we looked at that trellis chart, we're really creating bins. And when I think of bins, I'm not using a continuous value. So I'm going to make that index discrete. So right-click the index and convert to discrete. Bring it on the view. So you guys can see that all right. What it's doing is just saying from the top, 1 through 49, just rank my values or index them. So now let's figure out how to make that restart every 7 values. So I'll create a new calculation. Let's say index. And then I'm going to be honest, I just make notes for myself on this because I do not memorize how to do this type of thing. So like I said, the important part of this is to actually just understand how to get there and understand how to use the tools, and then make notes for yourself and cheat. So, so the trick here, okay, if we take our index, let's think about this. We could divide it by 7, right? That would put it in almost like chunks of 0 through 1. We'd get floating numbers. We want to figure out how to actually make those all roll up to like a 0, a 1, a 2. So what I'll do is I'll divide this by 7, and then we can take the integer of this. Int And once again, I'm going to make this discrete. We're almost there, but I'll show you something in one sec. Let's call this our x. So we're starting to actually get closer, right? This is the idea, is that we chunk some of these into zeros, and then for the y-axis, it would go 0, 1, 2, 3 through 7, and then restart for every one of these new bins. The one thing we are missing here is this actually doesn't add up correctly. So 0, so that's 1, 2, 3, 4, 5, 6. We want this to happen every 7. And there's just a nice trick to that. If you just take your index and you subtract 1 from it to make it start from 0, it will work correctly. And you can see that value there now populates with 1. So now we've got part of this down. We've got an x-axis or a y. So part 2 then, now is where we start using something you maybe have never seen before, but it's a similar context. So index, I'm going to do that same thing, -1. And then what we can do with this is we can use something called a modulo. Does anybody know modulo? You probably learned this in like 3rd grade or 5th grade or something like that. I still don't really know what it does, but it works pretty well. It takes the remainder of something, and essentially we can use this to then get those values repeating. So if we don't need the int on that one. We're good to go. Let's call this y. And make that discrete first. How are we looking? Good? We're going to 6, but that's OK because we're starting at 0. So that's not an issue. We could add 1 to everything if we were really bothered by that. But now we have unique coordinates, right? 0, 0, 0, 1, 0, 2. And then we come here and we get 1, 0, 1, 1. And if we go through this, there are 49 unique coordinates that we've created. So we don't need this index anymore. That was just to show you how the index works. Now, if we leave state up here on the rows or columns, it's going to try and just push itself all the way down. And we don't want that to happen. We don't want it to be used on the y or the x-axis. So I'm going to actually put state onto detail. And what's interesting is you see my x and y just go to 0 now. So the reason for that is these things are based on a view. A table calculation is based on what's in a view. It looks at your view and it says, how do I compute? So we need to tell these things specifically how to compute when state is not there. So if I right-click on this, on the table calc, and I say compute using, I can choose state rather than table down. When it's table down, there are no states to go and calculate on. Do the same thing for the y. And now when we bring state to detail, you can see that we've got all these unique coordinates. So we're getting pretty close. And the rest of this starts to come down to really just formatting, right? Make this the entire view. Instead of blocks, what do I want as my mark type? Pie chart? All right, so I change it to a pie chart. And I think we had category on color, and we had something like sales on the angle. And so really kind of simply now we've created this trellis chart. Ta-da! So like I said, I don't expect you to just totally get that indexing stuff that I just used, but the truth is, obviously, I don't just totally get it either, and it's something, as long as you understand the concept of it, you can use it to create things like this. And what I would actually really suggest you do is start looking at graphs now and breaking them down. Say, okay, it's got a color component, size component, x and y. All of the craziest graphs you've ever seen just have these fundamental concepts about them. So, understanding the problem is very critical to our success. Does anybody have any questions on that? Go ahead.
So, in the groups you had the state on the bottom, right?
Yeah.
But if you drag state to the text, technically won't that put text in slices?
Let's see. So if we bring state and we put it on text, it's going to just add it to the text of each individual slice. Because text, what it does is apply to every single mark in a view. And so technically with a pie chart, this is an individual mark. not the whole pi.
Right. So in the previous, previously you had the state, name of the state on the bottom.
Name of the state.
Yeah, in the previous view, you had state on the bottom.
Oh, I don't even know how I did that. Let's see. You're not supposed to ask those questions. So what I'm probably doing there is doing something. I might be doing another trick where I actually, let's see if we make this bigger. I might be doing a trick where I say only show one mark per. So you could actually write a second table calc here. I'm guessing there's an easier way where I actually go in and I say for each mark, make another index. And it would be 1 through 3 for each pi, right? And I would say if the index equals 1, then show me the value. And I could put that on text. I'm guessing there's a simpler way to do it, but I don't actually remember what it is right now. Yeah. After this, what I'll have you guys do is we'll have surveys to go out. And if you put your email in there and ask me a question, I'll answer it for you.
This is in the workbook, though, right?
Yeah, and this is in the workbook too. So the solution should be there. I just don't have that open.
You can also dual access the other index.
You're all over the dual accesses now. Any other questions?
Dual access.
We can try it later. We'll test it out. All right, where are we? So this is a problem called open and active items. Is anybody familiar with this? This is a really hard one. It took me a long time to truly get. The question is, on any given day, month, he's got it, yeah. So on any given day, month, year, how many items were active or open? So it seems kind of simple. It's just like a date, right, that you would put something on and count. So this is a view that we're looking for. Every row, so everything on the x-axis, that's an individual day within a month, within a year. And then we're counting the number of orders in this case that fall into those. So let's take a second to try and understand this problem. This is what the data looks like. For each order, you've got a ship date and an arrival date. And so the question that we're asking is not how many orders were shipped at any given date, not how many orders arrived on any date, but at any given point in time, how many orders were en route between their shipment and arrival or on either of those days. So we've got the order ID, we've got the dates, so why can't we just count the orders per date? I think you're starting to get that based on what I just explained. But if you didn't, here's what we're missing. We don't actually have all of the data. Because for that individual order, we know when it shipped, we know when it arrived, but we don't know the date, or we don't actually have the mark of data to tell us when it was en route. So this is a problem that I run into a lot. And it doesn't have to do with just this simple one where we have a start and an end date. This happens all the time. And the problem is when you don't have enough data and you need to create data. And so this is where my sales reps are going to get really mad at me, but this is where you need to take a step outside of Tableau. So let's work backwards on this. So if this is where we need to get to, we need to know every single date that an order was made on. And this is what we want to get to. So we're starting at the end of the problem. We're saying, OK, this is where we want to get to. So let's think about what we can do to get there. Each order, we want to know every single date, have one row of data for every date that it was en route. And this is what we have. So how do we go from here to here? Well, at least we've got a clearly defined problem. We know how to steer towards it. We could go in manually and just write these in, right? But if you have a lot of them, it's going to be kind of hard. So I'm going to find some way to basically automate this and do it in iterations. This is the goal, right? If we have every single possible date, we know our dates, well, we could just use some simple math, right? This is stuff we learned in middle school and high school. So is the date on the right-hand side, is it between the start date and the end date, right? Greater than or equal to the start date and less than or equal to the end date. And if we actually go through and we test this, which is a really good idea if you're new to this, go through and test it. OK, that one is not correct here. That would be false. 4, 6, that's false. 4, 7, OK, that's correct because we're using greater than or equal to. And then we go through and we say, okay, these are all check, 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 but those last two would not apply. So if we can find a way to then apply that math in Tableau or outside of Tableau, we can get the data that we need. Is anybody familiar with like programming languages? Everybody tried to like write in R or Python? This is like writing a for loop. Like go through each date and do this thing and check it. And so we need to find some way to basically create a for loop to get this data there and do it automatically. So that's what we're going to work on here. So like I said, any time that we have this problem, where we don't have enough data, we tend to have to step outside of Tableau and find ways of creating that data. So that's what we're going to do. Let's take a look at the table. So here we go. We got each order. We have a ship date and an arrival date. And what I've done beforehand in this class is I've created a master date table in that same Excel doc, because this is going to allow me to actually connect these two things together and write that type of math on there. So here we go. If we have every single possible date, so 1/1/2010 is the earliest date that I possibly have. And I actually just threw this all the way through a couple of months into 2011, even though we don't have all of that data, just to give myself some room to breathe with. Another way to do this, a lot of times I see this as people just have to do this in Excel. That's where the data is. Another way to do this is on the database, to actually create this on the database. If you want to get really, really fancy, you can actually write custom SQL on a SQL database to create a table like this and do it very automated. So there's some cool ways of doing that. Definitely involves a little bit more technical skill to get that done. But like I said, we're all about the concept here. OK. So now that the data is ready, we can connect to it in Tableau. I'm going to go connect to an Excel file on my desktop. And we've got this orders file. And this is just a really kind of, it's unfortunate that this is what we have to do. But for this specific problem, if you're using Excel to do the stuff that we want to do, you can't just open it. You have to use the legacy connection, because the legacy connection supports greater than or equal to, which is what we're going to do in our join here. So that drop down right there, open with legacy connection. That's nice. What's that? Oh, did I do text? I have too, a lot. Oh, man. Let's see. One more idea. What's that? We'll just skip it. This is the one that you really wanted to see, too.
This is nothing before, it has to wait, you wait like 30 seconds for it to be closed.
Anybody have good jokes? I'm also going to try one more thing. I'm going to try reopening. Come on. Trying to think if there's other ways of doing this in here. That's a good idea. Read the error. An error occurred while communicating with the Microsoft Excel file. The connection to the data source might have been lost. You guys are really good at my job. This is what I have to do all the time. Access privileges. Let's do this. You know what we can do? I think I can open up the solution. We could walk through that. This will work, hopefully. So this solution workbook is going to be available to everybody, so you can download this after. All right, yeah. So here we go. This is the original data source, just connecting to the orders and the shipments and arrivals. And so here's our solution. Oh no! What's wrong now? Man, these computers don't like me. So let's just walk through the concept then, because that's all you really need to know. And I can do that. I'm trying to think what the best way to do it would be. We'll just go in Excel. All right, so what we're going to do is we're going to connect to these two files. I'm going to essentially just build out what the connection screen looks for you, like an example of it. So you would connect to this Excel file, and you're going to get access to the two different tables that we've just created, the master and the actual data set. What's really nice in Tableau 10, too, is now you could do this across different data sources. So if you couldn't figure out how to do it in SQL, you could actually make your master in Excel, and you could join these two things together. So we've got our two tables, orders, and we'll call this master. And so then I drag and drop this guy over. And I'm going to drag and drop, in this case, the master table. Can you guys see this? I'll bump it up a little bit. So we'll drag this into our connection screen. And the first thing that I would do is bring over the master. The reason for this is it's the more detailed table, and I want to keep all the information from that. Because if there's a case where maybe on any given day there was no orders in shipment, I might want to know that, and I might want to keep that data rather than removing it. So the master goes over here on the left, and the order, the actual data, goes on the right. And so now what we need to do is set up that basically join clause that we talked about, which is, does the date fall between the start date and the end date? So the first part of this would be to connect each order ID. And this is a critical step that people can miss. So we need to make sure that the order ID, let's give ourselves one more column, is equal to the order. Oh, in this case, sorry, we don't actually need that. This is a more, in some scenarios, you'd actually have to set this equal if you're going with like more granularity. In this one, since it's simply just the dates on each one, we don't have to do that. So we'll delete that. So what we need to do, let's set up that the master date. Let's check if it is greater than or equal to the order ship date or start date or end date. Yell it out. What do you got?
Ship date.
Ship date. And it's easier if you actually do just think of these as start and end. So ship date is my start date. So if it's greater than or equal to my ship date, then all the values after, yeah. OK, master date. What do I do here? Less than or equal to, yeah. You guys are good. Arrival date. Yeah, so if we set up this join, what it's going to do is it starts out row by row. So it looks at an individual row of data, and it goes through these checks on the other data set. It goes through every row of data, and it checks, is it true for this logic? And essentially, what it will do is iteratively go through and create all the new rows of data that we need. And then we have a single master date. Every row of data that the order happened on those or was in shipment on those master dates. And then we can just count the unique orders that fall on those master dates. So this concept is widely used for a lot of different solutions. And it's kind of one of my favorite ones. It's just really interesting to solve. You can do a ton of stuff with it. So once again, ta-da. This one's a little less exciting. Yeah, you'll have the solutions. They should open up on your computers unless you have the same issues that I'm having here. And then we can talk later. So any questions on this one? Does anybody ever run into this before?
Oh, yeah.
Yeah.
Yeah, I went through a lot of hoops and used parameters and things like that.
Yeah, there's definitely workarounds you can do. You could get like crazy with table calcs and use domain padding, which creates data in Tableau. But all of that is a workaround. And so what I'm trying to get you at is thinking about like how do we need the data to do this successfully?
We did this with trouble tickets. And an additional problem I run into is people, in addition to trouble tickets being open and closed, they also get transferred in and transferred out. So my data set, I'm usually looking at those tickets, and I want to know what the state is on a certain date, whether it's ours or somebody else's.
Mm-hmm.
It's tough because the transfer data isn't always in the data set.
Yeah, so this can get more difficult if you're dealing with not just like a simple start and end, and you have like multiple stops in between. After this, I also have some good follow-up questions. They're fairly advanced, but they're really interesting. And so other kind of variations of using the same technique. Any other questions? You all just get it? It's easy. This took me so long to figure out. Like I sat down with a pen and paper, and I literally would like make these charts, and I would go through and do these checks over and over again, and I was losing my mind. So I'm happy you all just get it. That's good. Or at least they're telling me you get it. All right, so we got one more. So this one is called the second purchase date. If anybody actually came to my level of detail expression session, the one, or you can come again, this is one that we'll do in that session. So sorry if it's a repeat for you. But the second purchase date is a really interesting one. You probably could apply this somewhere or another. The way that I'm going to apply it is different customers. So the thought here is, okay, customers purchase things over time. Sometimes they purchase multiple things. Let's try to figure out what the time is between a first and a second order, and let's use that to try to analyze our customers. So the question that I'm going to ask is, what is the percentage of customers that made a second purchase in under 6 months? There's a lot to this question. You might not realize it at first, so what I want to do is start from the back. We'll use that fancy word chunking, and we'll break this into smaller problems and work back from there. So what percentage of customers made a second purchase in under 6 months? So I want you to try and envision what the graph looks like, or the answer looks like to this question, right? It's a percentage. And if we think about percentages in Tableau, that's a really easy thing to do. Percent of total. That's a table calculation that we can write. So if we have this view where we have second purchase speed, and we have over 6 months and under 6 months, then we can very easily count the number of customers that fall under each one of these bins, and then turn that into a percentage of total. Straightforward. But if we were going to do this, then we would need to somehow bin our customers into two different groups. We need the 6 months and the over 6 month group. So that's actually pretty simple, right? We just say, well, is the months to second purchase greater than 6 or greater than or equal to 6, depending on what you want to do? That's pretty simple. Everybody's done that type of calculation before. It's just row level. Okay, so we've got our second purchase speed. Now, if we have our months to second purchase, how do we calculate the length of time between a first and a second purchase? This is pretty easy too. You just do a date difference. The date difference in months between a first order date and a second order date. And the requirement now is, if we have this date calculation, this involves how many columns? 2 columns. I keep accidentally giving away my answers. Okay, so we need 2 columns, right? We need a first order date and a second order date. So we need 2 fields, first order, second order. But this is what our data looks like. We have the customer and the order date, but we don't have something that tells us the first and the second. So there are our first and our second order dates. So let's break this problem down and look at it a little bit differently. So we're going to change it up. The concept is the exact same. We're going to use a different type of data. We're going to find the second and highest scores for exams for an individual student. So for this student, John, his first highest score is 100, second is 98. And the concept here, instead of doing a date difference, we'd want to find the difference between their first and second score, right? So it'd be 2 in this case. Now, if we're looking at a single column of values and we want to basically rank them, that's also a table calculation. So we would use a table calc to rank them. This is going to cause you a lot of trouble. If you start off with a table calculation on a complicated problem like this, you're trying to build on top of something that's already very view dependent, and it's just very, very troublesome to do. So it's not going to be a great solution, though you could hack it. In reality, what would be much easier is if we basically, you all know the pivot function in Tableau? So pivoting means taking data and changing the shape of it. So we want to pivot our data out of relational format into the stuff that you see in Excel, where you have a column for every single year instead of a single column of date values. So if we were to unpivot it, we could really easily get a first and a second highest score and then take the difference between those, because a columnar calculation is really simple, as you're used to. So first minus second equals 2 in this case. So then how do we calculate the first and the highest scores, right? We know now we've backtracked all the way from where we need to get to this point in the problem where we probably get stumped. How many people are familiar with level detail expressions? All right, so this is a fairly advanced use case, but it's a really, really powerful one. It's really easy to find the largest of something per a customer and create a column of that using a fixed expression. So right now, we're fixing the maximum exam score to the student. So that would give me 100. And that does in the background, it actually creates a table at the level of detail of that level of detail expression. So fixed student, 1 row for each student. So we get the max exam score is 100. Then what we want to do is, okay, we can see that populates 100 for all those rows. Then what we want to do is find calculation 2. So for calculation 2, I could actually use that same logic if I filtered out the highest score. So here what we're doing is we're saying if the exam score is less than the first best score, then give me the exam scores. So what I'm going to do is I'm going to show a table of all of those exams that are not the highest. From here, I can do that same exact logic as I did in the first one. Fix the max of those values to the student name to get the second highest score. Now, there are inevitably more problems you would run into this if students both had the same highest score for the same subject, something like that. But this is the concept. It's your job to now figure out how to apply it. But we've got the foundation. So what that would do, we've got these 2 tables, first and second. Some people will get confused. They'll say, OK, well, if we subtract 1 from the first and the second, we get a bunch of 2s. What if you sum those up? Would it be incorrect? The answer is no, because the calculation actually happens at that lower table. Tableau is just really smart about that and does some impressive things to make your life easier. So let me see time, if we have time to go over this. Yeah, we do. If you want to learn more about this stuff and get more in depth with LOD, I'm doing a Jedi session this afternoon and tomorrow. All right, so we'll use that same data set we used for the trellis chart. Customer name, bring out the unique order dates. So we've got our customer. So let's go through the first step. The first step is really easy. I just need to create a calculated field. And per customer, what do I want to find? The min. So max would be the last purchase they made. So this is our first date per customer. So I bring that out uniquely. You can see, all right, let's check this. Always a good idea to check this. So 422 is the first one, and it replicates across all rows for that customer. So we're looking good. Creating a second calculated field. I'm going to break this up into multiple steps to make it a little more visual for us. So what's the next part? Yeah, so we want to show all the order dates that are not the first order date. So if the order date is greater than the first date, then show me the order date. So not first dates. All right, that's looking good, right? So that's what we want. We've got all of our dates for that customer that are not the first one. And so very easily then we could take the max of this. Your choice. I would prefer to just do this min. Nice. I would prefer to do this in the same calculation, but you could definitely break it up into multiple calculations. So fixed customer name, max. Oh, man. Oh, no. Do you want to do it? All right, here we go. Min. This is why you guys are here, because I can't do it on my own. All right, we're looking good. All right, let's watch this happen. So 513 should now replicate across all those rows. Beautiful. All right, so that's pretty straightforward. Now, the rest of this is actually really easy to do. We just take the date difference between those in months, and then we create some logic around it, and then we count the distinct customers that fall into each one of those bins. And here I'll just bring up the solution rather than walking through that.
What happens if they don't order
If they what?
They're a single order customer.
Yeah, definitely. So the question is, what about a customer who doesn't have a second purchase? So what is the date difference between some date and null? Null. So we just get nulls for those guys. So in this case, the logic, you would either include that in the logic. You could say, if it's null, then no second purchase. Otherwise, something else. Or you could just filter them out. It really depends on what you want to do with it. Yeah, and I think, so I did that actually here. So no second purchase. And we can see the percentage of customers. So customer on the view, months to second purchase. So I first did the date diff. That's straightforward. And then I just wrote some logic around it. So if the months to second purchase greater than or equals 6, then greater than 6 months. Otherwise this. Otherwise no second purchase in this case. Ta-da. Do you have questions on this one? Is that just really scary? Slightly? It's a hard concept to get. It's a good one, though. And you can do tons with this. We use this to look at something like, well, what's the difference between customers for us at Tableau who first purchased desktop versus server, and how long does it take for them on average to make a second purchase? So tons of stuff you could do with that, and you could apply it to really vast amounts of things. To compare 3 dates? Yeah, I mean, so you could theoretically keep iteratively going through this and saying, well, if it's greater than the second date, if it's greater than the third date, and go through, and you're basically building a for loop by hand. No? All right, I'll do a quick kind of recap, and then I'm also going to be hanging around for questions as well, and we can ask questions too after. All right, so closing. So let's come back to the airport, because this is what everybody actually does. What I realized is I went through this whole creating this PowerPoint and thinking about problem solving. I was like, am I actually using these techniques? And I realized I wasn't at all. And so if we come back to this airport problem, this is what I actually do when I go to the airport. I say, okay, I got to leave for the airport at 10 a.m. What if I wake up at 8 a.m.? And then I say, okay, well, that gives me 2 hours. Well, how does that break down? Now I have 45 minutes to get ready, 30 minutes to drive, and 45 minutes to arrive at the airport, and I'm going to be a little stressed out because I like to get a little bit earlier to the airport. It's not as elegant, right? When you start from the beginning and try to work forward, you're almost just guessing and you're throwing out numbers, because now I have to restart. And I say, well, what if I try 7:30 or 7:15? And you're essentially creating more work for yourself rather than slowing down, taking the time to understand the problem, and then trying to work backwards. So it's been kind of fun doing this, because now I'm finding myself constantly trying to force myself to slow down, think about the problem, and work backwards, even for trivial things like going to the airport. So just as a recap, 3 concepts we learned today in terms of problem solving. So understand the problem. Take the time to truly understand what you're working with. Work backwards. So figure out an end solution that you're trying to get to, a simple one that makes sense. And then from there, break your problem into smaller problems so that you can accomplish them each. So these 3 different concepts, I forgot to really talk about the last one, but visual layout. When you're looking at a visualization and you're trying to understand how do I morph my data to look like some graph, you're typically dealing with a visual layout problem. And to be honest, this is something that extends beyond Tableau. The creating data problem, what we realized is that we didn't have enough data to populate or answer the question that we wanted, so we had to actually go in and create new data points to do that. The reshaping problem, that's what we did in that last one. Essentially, our data set was not in the way that we wanted to easily answer our question. So what we did is we used level of detail expressions to pivot it. This is the one that I see probably 75% of the time. Everybody has these questions that involve their data being slightly shaped differently, and almost every single time, level of detail is the solution. So if there's one thing I could tell you to really focus on if you want to solve problems like these, it's learn level of detail. So what's next for y'all? Can't see that. So the quickest way to do this, the Tableau Challenge Workbook is hosted on Tableau Public. You can try and search it on Google, although it gives me a hard time every time. And this is that library of challenges. So if you wanted an ETL problem, ETL would typically be a creating new data problem, or level of detail reshaping problems. You can come in here, you can search these. They go from beginner to Jedi. Anything that's blue has a solution. Anything that's gray, you got to solve it yourself. Or ask the community. I promise you the answers to every one of these problems is somewhere on the internet if you learn to find them. Or if you're really, really stuck, maybe you can reach out to me. But once you click on these, you can download the challenge right here. It downloads a starter workbook as well as a solution workbook if it has one associated with it. So it's a great way to get started. Challenge yourself. Show this to your coworkers. Tell them to try it. You can race to finish it. So lastly, there's a really easy URL to remember. It's called tableart.co. This is not my blog. This is just a place for resources. But essentially, everything from today is up there. We've got, here we are. That top one, we've got follow-up activities if you wanted some challenges specific to what we did today. The solutions from today, the workbook, as well as the PowerPoint to walk through on your own. Everybody got that? Tableart.co, easy enough? Challenge workbook, you can find it up there. Lastly, would very much appreciate it if you all filled out surveys for us. I actually get to look at these surveys tonight, and if there's anything that you think would help the session, I can improve on that tomorrow. We use data at Tableau. We're a data-driven company. If you're interested in doing more of this stuff with me, I'm doing a pretty advanced session on level of detail expressions. It's called Solving Real-World Challenges with Level of Detail Expressions. I'm going there. It'll be tomorrow at 9 a.m. and then this afternoon at 1:45. So take a look. If it's not full, you're more than welcome to come. Thanks a lot for coming. I'll be hanging out for questions too.